In this section, we're going to look at the motion of an object sliding down a plane and see if we can derive the equation of motion. That is an expression for the velocity and position and acceleration of the object. So, as usual, we'll start by drawing a diagram. So I'm going to indicate my inclined plane. I'm going to have it angled with an inclined with an angle theta with respect to the horizontal. We're going to draw our object. The object is sliding down the plane, so we'll draw our velocity arrow. This object is not assumed to be traveling at constant velocity. In fact, it is assumed that it is accelerating. So let's draw in an arrow for that, acceleration vector. Now let's consider the forces on this object. So we have the weight of the object, as usual, pulling straight down. Call that Fg, force of gravity. And we know that that is acting along the plane. A component of that weight will act along the plane, down the slope. So we'll call that component of the gravitational force Fs, the force down the slope. We also have the normal force, which is a component of the gravitational force that is pulling the block against the slope. So we'll call that Fn. And we also have, of course, the force of friction, which is opposing the motion of the block. Since the block's velocity is down the slope, the force of friction is up the slope. So now we've drawn all the forces that are interesting in this problem. And we should also just take care to define a coordinate direction. So let's decide that the positive x-axis is down the slope in the direction that the block is moving. So that's the x direction. Now we're ready to apply Newton's laws. Newton's law says that in the case where an object is accelerating, there must be a net force. So let's write down an expression for the net force. F net equals the sum of all forces in any particular direction that we might pick. So the direction we're going to pick is along the plane. So I've chosen my x direction along the plane, so it's not this axis, it's this direction. So let's try and do that now. So forces in the positive x direction are Fs, the component of the weight down the slope, and that appears to be the only force acting in that direction. And there's another force acting in the other direction, the force of friction. So let's add that one. Force of friction. Okay, now we can substitute in what we know about these forces. So this angle here being theta, this right triangle here made by the force vectors, as we went over in the lecture, we can show that this angle in here is also theta, and so Fs is equal to mg sine theta, while the force of friction, which is acting in the negative x direction, is minus mu k Fn, or mg sine theta minus mu k mg cos theta. That's F net. Now we also know from the second law that F net equals ma. The acceleration experienced by the object is proportional to the mass and the net force. So let's put that in. So ma must be equal to mg sine theta minus mu k mg cos theta, which we can simplify because we see that the mass appears in all the terms and therefore can be cancelled out. So we now have our acceleration, take out the common factor, so this is the acceleration of our object as it slides freely down the slope. Now what can we do with that? Well, we can use that to find out the velocity of the object, because we know that the constant acceleration we know the following, right? We know that v is v0 plus at, and we know that x is x0 plus v0t plus 1/2 at squared, which we get, of course, by differentiating the definition of acceleration. So let's apply those ideas. what do we get? V then is V naught plus G sine theta minus mu k cos theta t. X naught plus V naught t plus, or is it plus or is it minus? Let's be careful here. One half G sine theta minus mu k cos theta and t squared.